Hello everyone, welcome to my channel. So today we will discuss about Google Kickstarter round G curling problem. Okay, this took some time for me to understand the problem, and also it also took a lot of time for me to find out the solutions. There are so many minor details which needs to be considered when you create the logic. So I will discuss all these details in deep. The problem statement states that there are two teams who are playing the game curling. Both teams are given 8 stones each. So one team gets 8 red stones, another team gets 8 yellow stones. And as the game progresses, the number of stones reduces. Okay, I'm not clear how the game is played, but the important point which is useful for us is how the points are calculated. Okay, so there is a circle house of radius RH, and also every stone have a radius, and let it be RS. Okay, and we can define stone position using XY coordinate, so that will be given in the input, and this is the visualization. So, and here we have two red stones and one yellow stone, so, and this is the radius of RS. So this center point, right, is nothing but XY coordinate for this particular stone, and this is the XY coordinate for this particular stone. Okay, and so on. So, and this is the house radius, and it starts from the center of. Okay, so I hope this is clear. And now let us understand how the score is calculated for this game. Okay, so we need to calculate uh, the number of stones inside the home circle. Okay, so here we have 2 points for red and 1 point for yellow, but this is not only one condition, but we also have to count all the number of stones closer to the center than the opponent stone. For example, here we have red stone closer than the opponent stone. Okay, so red gets 1 point, and this is not considered because before this we have yellow stones. Okay, that's why we have 1 point for red, and yellow we have 0 point anyway because this is closer to the center. But if in case this is outside or maybe somewhere far, and then we have 2 points for red. Okay, I hope this is clear. Anyway, as we progress, right, discussing various examples, you'll understand better. Let us try to understand the sample input structure. Okay, here we have two test cases, and let us split them into two. And for every test case, we have first they will define two integers representing the radius of the stone and the radius of the house. Okay, here the radius of the stone is 1 and the radius of the house is 5 and 10 and 50. Then followed by they will be giving you the number of red stones. So here we have 2, here also we have 2, and followed by n lines of the coordinates. Okay, 2 lines of coordinates, uh, uh, which is indicating where the stone is placed. Then followed by we have, for the second player we have m number of yellow stones and where are the yellow stones are placed. Okay, I hope this is clear. Let us try to visualize this in next slide. So let us consider the test set one. Test set one is pretty simple. We have to consider only one set of stones. So in the given sample input, we have two test cases. Considering the first set, we have these visualizations. So the first two integers indicates the radius. So radius of the stone and radius of the home. Okay, and there are four red stones, and these are the positions 1 minus 1. So this is the stone 1 and minus 1, and second one is 6 1, and third one is placed at 0 6, and fourth one placed at minus 5 comma 0, and we have 0 yellow stones, so there are no yellow stones here. Okay, and to calculate the points, we need to calculate the number of stones which is in the house, and it is closer to the center. That is, first condition is the number of stones in the house. Second condition is that it is closer to the center at point 0 0 than all the stones of the opponent team. Okay, since we don't have opponent teams, so only we have to consider the first condition only. So it's pretty simple here. So we are considering this one 0, and even though it is like half inside and half outside, also we have to consider and we are considered even though it touches slightly. For example, here the radius of this stone is 1, so it is placed at 0, 0,6 this point, okay, and radius is 1, and the radius of the house is 5, so it is just touching the circle. So we are considering this point as well, this 1, 2, 3. Okay, this one also would be touching if the points are like 6, 0. Okay, but since it is like 6, 1, it is slightly away from the home. So we the score here is 3, and for score for yellow is 0. So 3, 0. And in the second, let us now try to understand the second set. In the second set, we have the rate. I'm just increasing this particular the scale because we the stones were placed at 200 x coordinate and 200 y coordinate, and the other stone is placed at -3, -4, which is near to the center only, and the radius of the house is 100, and radius of the stone is 10. Okay, and we have 0 yellow stones. So if we again consider how many stones are inside this circle, we have only one. So answer is 1, 0. Okay. Before moving to test set 2, let us try to understand this figure which is present in that analysis tab. So here, initially when I was trying to understand the problem, right, what I was thinking that we have to consider the points red scored 1 point, yellow scored 2 points. So I thought output is 1 and 2, which is wrong. Then I thought maybe the number of stones we have to consider and then subtract. For example, yellow have 2 stones and here we have 1 stone. So 2 minus 1 is 1. So yellow scores 1, 0, 1, which is also wrong. But what we need to consider here is the red is closer to the center, and after that we have yellow. So that's why red scores 1 and yellow scores 0. And in this case, there are four yellows inside the circle, okay, inside this home, but this particular red is coming before this fourth point, okay. That's why we should not consider this point, we should consider only these 3 points which are closer to the center. So we have yellow scoring 3, so 0, 3 is the answer here. And in this case we have 1, 2, 4, 5 yellow stones and 2 red stones, and since this particular stone is closer to the center, we should consider red. After that we do not have any red because first we have yellow, then we have red, so then that's why we have red scoring 1. And here, since all the stones are outside the circle, we have no 0 score. I hope this is clear. Let us now try to understand the test set 2. Let us try to understand the test set 2. So here we have both yellow and red stones. So here we have two sample data set. So let us consider the first one. So here we have the radius as 5 as house radius and 1 has stone radius, and we have two red stones placed at 1, 0 and -3, 0, 1, 0 and -3, 0, and one yellow stone placed at 0, 2, 0, 2. Okay, so we have to consider how many stones are inside the circle, and also we have to see their position from the center. So this stone is very closer to the center, and after that we have yellow stones. So we have to ignore all the other stones. Since this is closer to the center, so we have only 1 point for red. But just in case if this stone also comes closer, let's imagine instead of 0, 2, let's change it to 0, 1. Okay, then this stone will be closer to the center. Okay, also, and both are at equal distance from the center. Then in that case, the point will be 0, 0. I hope this is clear. Now let us try to understand the second set. And here we have the two radiuses as 10 and 50. Stone radius is 10, 50 is the home radius. And we have two red stones and three yellow stones. And these are their coordinates. And if you try to calculate the score, we have these two stones inside the circle and also closer to the center than this stone, this stone, okay, because this stone is placed at 59, 0, and this is comes before that because This coordinates for this is minus 40 and minus 31. Also, before this stone will come. Actually, the figure is not very clear, but I hope you are understanding the point. Here we have 30 comma 40, so this is slightly closer to than this one, because here we have minus 40 comma 31. But if we change this to minus 31 comma 40, then both will be equal distance. Then we have to consider only one stone. Since we have these two stones closer to the center, we have the point is 0 comma 2. Okay, let's try to understand the next one. I created this custom data set, so you can just pause this video and try to understand what is the output here. It may look little difficult, confusing, because we have four red stones and four yellow stones, so placed at randomly positions. But if you see properly, I have placed one stone exactly at center for red, 0 0, and also one stone at 0 0 for yellow also. So both are actually here overlapping. So since there are two stones, so it's not very clear, but there are two stones here. That's why the output is 0 0 here. I hope this is clear. Let us now try to understand the logic. To understand the logic, let us consider a simple example. That is, we have one test case, and these are the radiuses, and we have one red stone and one yellow stone. So placed at these points, and the output here is, you know that only one stone is inside, one is outside, so 1 0. And now, mm, as per logic, we need to consider the distance, okay, from here to the center and from here to the center. And also, we have compared the distance with the radius. Okay, so to calculate this distance, we need to use that Pythagorean theorem. So, so we have these points like 50 and 100. So which is nothing but 100 is the distance, the vertical distance, and horizontal distance is 50. And just draw a triangle, so that this distance is nothing but the square root of this distance, squares of this distance plus square of this distance. Okay, so same thing here also, we can use the same logic here, even though it's not a triangle, since the point is 0, right? So anyway, it doesn't matter, but we can use this also here. I hope this is clear. And we have to compare this with the radius, but we also have to compare this radius of the stone as well, because if stone is placed here, right, then also we'll consider that radius as well. So for that, let me show you in the next slide. uh, I will just change this value to 210, so that it just touches the surface of the hole. So we have to consider that also. So the output is 1 comma 0. So if I just find out the distance, right, here we have uh, 10 is the radius, and here we have 200, so it's nothing but 210. Okay, 210 square and square root will get cancelled out, it's 210 distance. So if it's even placed here, no, it's very difficult to find out the exact point here. That's why I consider this point. Otherwise I would have considered this points and all, which will come point something. That's why. So anyway, I hope this logic is clear. So we have to consider the overall radius, that is like 210, when you do the logic. This point I missed in my code, then later I added that. So I will explain the pseudo code and the code which I designed using Python in the next video, since this is now very long explanation. Okay, thank you very much. And if you like this video, consider subscribing to my channel. And yeah, have a nice day.